You can create an array with a dynamic memory allocation mechanism using keyword new. So let me create another file ex5.cpp int main. So let's define a pointer, integer pointer p, and then let's create an array new int. With this keyword int only, I'm creating one single integer variable and the address is stored in p. But if I give a square bracket with a 5, then I'm creating a 5-element array, and then the address of the first element is stored in p. So if I draw the picture, what's happening is that line 2, you define a variable. Remember, pointer is nothing but a variable, but just special about it is you store address value there. So line 2 defines a variable p, and the line 3 new int 5 is to create an array with 5 elements. And each of the element is integer, so array size 5 is created. And the address of the first one, so this first one address, whatever it is stored in p. So we can draw a picture like that. P is pointing to the first element. The address of a first element is stored there. So that's what you got through line 3. And then now we can store the value inside the array created for int I is 0, I is less than 5, like that. And then remember that if a pointer is initialized to the address of the first element, then you can use a pointer as if it is an array name. So p I can use this way and then say that I times 10. So to test this one, let me open the terminal, g plus minus g ex5.cpp, compile that. Then let's put a breakpoint here, go back to the debug, run the debugger. It's there. Local variable p is defined. It's not assigned yet, so whatever it is meaningless. Step over. Then now the address of the first element created dynamically is this value. So some zeros, 1003 and the like. So that is the physical address of the first element, and that is stored in p. Then if I unfold the p, star p is the contents if I move to this address. So that is at this moment undefined, not assigned yet. So let's do step over. And the first loop is done. Then 0 times 10, 0 is stored there. So let's do step over again. I is 1, I is 2, I is 3, I is 4, and the loop is done. So let's go to the debugger console. So here P0, enter, and you need to scroll this window is 0, P1, enter, P1 is 10, it's because I is 1 times 10 is 10, and then P4, the last element, P4 is 40. So using dynamic memory allocation, you can create an array, and then you can use the pointer to have access to the elements of the array. Let me stop the debugger. And of course, once you complete using the dynamically created memory like that, then programmer, you are responsible to free the memory, because this memory is not deleted or deallocated automatically. So one single variable, you use the delete and the variable p, pointer p to do so, but p is now pointing to an array, so C++ requires a blank square bracket prior to the address to free the array, not a single variable, like that. So you you use a new, then don't forget to free the memory so that no garbage is created inside the computer memory. Of course, the main function ends, then program ends, then operating system claims all the memory dynamically created, so there is no garbage remaining in the computer system though. But just imagine that this part of the code is inside the infinite loop, like you have created the program for server like ATM server and the like, then it's supposed to run just forever. As a customer comes, use that, and one iteration of program runs, and then wait for another customer and so on. So if this program does not finish it, but it's a continuously running, then after using dynamically created memory or the array or single variable, after you use that, then you have to free the memory. Otherwise, that memory just remains in the computer, and then you no longer need it or use it, then the garbage is accumulated. That is called the memory leakage issue. So one single variable, you don't use this one, but the array is created, then you give empty square bracket to free the memory.